All right, on to oil or petroleum. This is going to be another one of those slides where you'll just want to pause and kind of add these into your table. It gives you some of the information again, piece by piece for the table, so I'll guide you through that real quick before you pause it. This is where do we find the oil. This is how much of our energy does it supply. And then of course the uses down here at the bottom. So now would be a good time to probably pause that. Right, this next slide is how we actually produce oil. Obviously, as you probably well know, have to drill wells to get at oil. That's what I was talking about in the little diagram earlier with all the different types of rocks and how the well had to go through that trap rock. And there are also some additional methods we can use to get more oil out of a well. They are called the secondary recovery methods. This might be something good to put in your miscellaneous box. Basically what they're going to try to do is put different things into the well to make more oil come out. That might be acid to help dissolve those channels in the rock to get more, remember that porous rock, to get more oil to come out. Sometimes they pump fluid under high pressure to break the rock that it's in, so again creating more channels. Also pumping water and gases into the well to force that oil to start moving. Finally, you can heat oil so it moves faster. That will take care of not necessarily getting more out, but having it happen more quickly. How do we process oil? Now, oil can be used for a lot of different things. You may be wondering where gasoline comes from and where this gas for your car fits into everything. Well, that's part of the processing of oil. First thing what we do is we distill it, which means we heat it up and it gives off a vapor, and then that vapor, depending on what temperature it's heated, can have different hydrocarbons that come off of it. We can capture those different hydrocarbons and make them into different products based on the oil. So then the next step after the distillation is what's called refining, and that's when we make those actual different products called petroleum products from those different types of hydrocarbons. So distillation is just the heating and capture of the hydrocarbons, and then refining is taking those hydrocarbons and making them into different types of products. Now to make gasoline, which we're all most familiar with, what you actually do is you use what's called a catalyst, a chemical catalyst, to help speed up a reaction. And the reaction is to join a bunch of small hydrocarbons that were made in the process of refining, join them together or bond them together quickly, and we get what we call gasoline. Okay, again, this slide is going to be mostly just information for your data table. Might fit into the categories that I've given you, or might fit into the miscellaneous. So you have to pause this for a minute and get that into your data table. All right, finally coal. Formation of coal. So what we start with for coal, again, is dead plants and animals, specifically in this case, dead plants that have formed something called peat. You may have heard of a peat bog before. I actually have an example of peat in class that maybe we'll get out sometime and I can show you what it looks like. It's a real light brown, kind of dried plant looking material. What happens is over time those peat swamps actually sink and put the peat under, again, extreme heat and pressure, kind of like what happened with the petroleum and natural gas products. And when that is put under high heat and pressure, we get what's called coal. There are different types of coal. The softest kind of initial form of coal, so the first type that's formed as the peat swamps are put under heat and pressure, is called lignite. As it gets under higher heat, we get what's called subbituminous. And then finally, the bituminous coal has been under pressure and heat for more than 100 million years. And that's the most common type of coal that we use in the United States because you're going to get the most energy out of that type of coal. Anthracite does exist. It has a very hard structure because it's been pressurized for a long time. Has the highest heating value, so it can get pretty warm, but it also is pretty hard to find. Fairly expensive compared to bituminous. I think that this is another slide that I'll just let you add to your data table, so you want to pause and make sure that you get these in the right places. Now, how do we get coal? Okay, we're not going to drill a well to pump coal out of the ground. This is a little bit different. It's a solid as opposed to a liquid. So what we have to do is dig it out. There are different types of digging or mining that we do to get coal. The first type is surface mining, which is safer and less expensive than the second kind we'll talk about in a moment. What they can do is something called strip mining, where huge machines, these earth movers, take all the soil and rock above the coal deposit off. So they're starting at the surface, kind of digging down, and then they can get the coal out from that way. And then finally, when they're all done, they try to return the strip mined land to its original condition. This is called reclamation. But as you probably well know, once a habitat is disturbed, it's kind of hard to put it back exactly how it was. And the second type of mining is called deep mining. It is more expensive. It's not quite as safe. This is when you hear people talking about miners that have died in an accident. It's usually those that are in a deep mine. There are different types of systems how they do this, but they're going to dig down into the earth, create like a tunnel. And in some cases they make these big rooms that are held up by pillars of the earth that they can go in and get coal out of. And other systems, they create these long corridors. It's called the long wall system. So there's long walls that have corridors between them where they can get the coal out. Processing and transportation. I'm going to let you, oops, went too far again. Let you pause and get this into your table. And just some additional kind of miscellaneous coal information. I talked about this a little bit already, but miners are often killed in accidents, especially those subsurface mines. This number is a little dated, so I'm sure it's higher since when I made this, but there have been 100,000 coal mine deaths since 1900. Right, so that average is about 1,000 a year. So it is a dangerous way to get fossil fuels out of the ground. Another problem with mines is that lots of times, again in those underground mines, methane, which is a poisonous gas, and carbon monoxide, which is also a poisonous gas, can build up in mines and be dangerous for workers. Another danger for workers is the coal dust itself gets lodged in their lungs and develops into what's called black lung, which often can become cancerous. A lot of acidic water ends up coming off of mines because they have to wash the coal, as an earlier slide showed, to get the sulfur out of it. And sulfur in water becomes an acid. And so that is not good for ecosystems. So we learned last unit, anytime you make the pH of a waterway, for example, more acidic, you're hurting organisms in that waterway. Another problem with coal is something that can happen. It's called subsidence, and that is when the land sinks in the area above the old coal mines. So the structures underneath aren't holding the land up the way they should, and so you just kind of have a cave-in, which obviously is not great either. Our coal reserves, as they are now, will last for about 200 more years, and then we'll be out of coal.